Hi guys, welcome to the video lecture series, and today we are going to discuss a new topic, that is binomial expansion, but in a very different way. We are going to express this binomial expansion in terms of integrals and derivatives. So binomial expansion in terms of integrals and derivatives, and it's a very unique way, very different way, right? So in terms of derivatives and integrals. So we will see that how we will represent the binomial form, the theorem, the formula, right? So we know that binomial theorem is given by a plus b to the power n, which is equals to a to the power n plus n a to the power n minus 1 times b plus n into n minus 1 times a to the power n minus 2 times b squared over 2 factorial plus n into n minus 1, then n minus 2, and then n to the power n minus 3 times b cubed over 3 factorial, and so on. But have you ever wondered that this form, that is n to the power n times a to the power n minus 1, this resembles the derivative of x to the power n, that is equals to n times x to the power n minus 1. So why can't we put here d over dA times a to the power n? What will happen here, right? If we put this into the formula, so we will again get n times a to the power n minus 1. And see here in this part, if we again differentiate this function, that is if we do d over d d squared or d squared dA squared times n into a to the power n minus 1, again we are going to get n into n minus 1 times a to the power n minus 2, and so on. If we keep doing this, we are going to do it, what we are going to get at the end, till what till which term we are going to do, it's dk over dA times k, sorry, k minus 1 times derivative, right, of a to the power n. All right, so what is this k minus 1? Or we can write here, this is simply not k minus 1, this is n minus 1 times, we are going to differentiate n minus 1. We can write n minus 1 because if it's a plus b to the power 5, then we are going to differentiate till the fourth derivative, right? d4 over dA4. So we can see here that we are just keep on differentiating and integrating the functions, and see here for this part b, then b squared over 2 factorial, and then b cube over 3 factorial. So this part resembles the integral, that if we take the integral of x, dx is x, then if we again take the integral of x dx, we get x squared over 2. If you again take the integral of x squared over 2, then we will get x cubed over 3 times 2. And then again, if we take the integral of x cubed over 3 times 2, we are going to get x to the power 4 over 4 times 3 times 2, and so on, 4 3 2, right? So we can see here that this binomial expansion is pretty much similar to these integrals and derivatives, right? So what if we write this expression, a plus b to the power n is equals to a to the power n plus the derivative of a to the power n, and then integral of this db plus the second derivative of d over dA to the power n, and twice the integral db plus then again sorry, it's second times 2 times, and then it's 3 times and it's a to the power n then triple integral of dB, and so on till n-1, right? So these derivatives and integrals are till n-1, and then we will again get b to the power n at the end, right? So this is the idea of a new way of thinking for binomial expansion or binomial theorem. And you can comment, you can think about it, or if anything is missing or any corrections are needed to this form. But this is a new way of looking at the expression of binomial expansion. And this expression is only for the derivation of this formula. And if don't apply this expression to the forms like this, let's say it's 1 over x minus 3x times 5, and what will happen if you apply the integral and derivative on this function? This is a integral, this is a function, so this will not apply to this form. Okay, so what you need to do is just apply on the formula. This form is only for this formula, and you can derive only the formula of binomial expansion, or you can remember the formula of binomial expansion in this form, and then you can see that if we do this, what we are going to get from here. Don't apply this expression on this type of problem, right? It's only apply the expression on the formula, that is a plus b to the power n. And look here, what is going to happen? It's a to the power n plus, then we are going to get n times a to the power n minus 1 times b. And then we are going to get n times n minus 1 times a to the power n minus 2 b squared over 2 plus n into n minus 1 into n minus 2 times a to the power n minus 3 b cubed over 3 factorial, and so on, right? So this is a new way of thinking or new way of looking at binomial expansion. Hope you guys will enjoy this video, and thanks for watching.